Quantum Prism is an AI-powered electronics diagnostic system specifically designed to diagnose and repair laptop motherboards. The role I built here is called the chief engineer. Claude Code acts as the orchestrator. It receives a fault symptom, reasons through the repair methodology, and coordinates three specialized subagents via MCP. The first subagent is the RAG Analyst. It searches a Qdrant vector database containing 277 knowledge chunks, all extracted from a 29-video electronics repair course. Each video was processed with Gemini's file API, converted to structured markdown, and indexed with 1,536-dimensional embeddings. The second subagent is Vision. When I have a schematic or a board photo, this agent calls a local fast API service at port 8900, which sends the image to Gemini for analysis. It reads component labels, pin numbers, voltage rails, whatever is visible on the board. The third subagent provides reference resistance values for known good boards, a baseline for spotting shorts or open circuits. The pipeline runs entirely through N8N. Four workflows handle the MCP server, RAG lookups, vision analysis, and reference data, all exposed to Claude Code as native tools. Here is a real diagnosis case: an Acer Aspire S3-391 laptop with no power response. The RAG lookup returned the power sequence methodology. Vision analyzed the 102-page Qdrant schematic. After mapping the charger BQ 24745, the input rails, and the gate drive circuit, we traced the fault. Input MOSFET PU402, a Toshiba TPCC 8131, was physically missing from the daughter board. The root cause: laptop receives 19 volts at the DC jack, but the voltage never reaches DC bat out because the input switching transistor is absent. Repair: source the TPCC 8131 GP and install it in the PU402 footprint. Total code: about 1,200 lines across 4 Python modules. Audio-video processor, RAG indexer, diagnosis agent, and the vision service. The system is fully operational, 29 course videos digitized, 3 MCP tools live tested end-to-end.